Hi, and welcome to Stay in the Loop, where we do not complain because we are solution-based. In our previous video, we learned how to divide 4-digit dividends by 2-digit divisors within word problems. And in this video, we are going to learn how to interpret remainders as we do our division. So allow me to put on my focals, and let's begin. Here is a new page that is going to be added to all videos moving forward where I am going to input the standard. So in this case, we are learning a 4th grade standard. And while we're not solving any multi-step problems, we are focusing on that division, specifically how to interpret those remainders when we are doing some division, especially when 4th grade where the numbers are getting a little larger. So let's see what I mean. A candy company is packing 1,275 pieces of candy into bags of 6 pieces each. How many bags can they make? Okay, let's reread. Let's try to understand. A candy company is packing 1,275 pieces of candy into bags with 6 pieces in each. So I have the number sentence being 1,275, which is my total. I do not know how they are going to be grouped, but I do know that there are going to be 6 pieces in each bag. So let's get to work. Starting with the big 7, I have my 6 on the outside and I have my total on the inside, with my first focus being on this 12. 6 times 2 gives me exactly 12. So now I can focus on the entire dividend by looking at those powers. My next power is going to be 20, and that equals 120, which is larger, but not as large as I need it to be. So I'm going to extend to my next power, which puts me at 6 times 200, which is 1,200. So that is going to be my magic partial quotient. When I multiply that, I get 1,200, and then I am subtracting, which gives me a difference of 75. How close can I get 6 into 75? Well, I can get 10 groups of that 6 in, which gives me 60, and I'm left with 15. So it means I can divide some more. 6 can go into 15 without going over 15 2 times. 6 times 2 gives me 12, and I am left with a remainder of 3. So I have 3 pieces of candy left over, with 212 being the perfect amount for the 6 pieces in each. So in terms of my answer, how many bags, I only need 212 bags. These 3 pieces can be eaten. I might give them to a friend, but they're not going to go in a bag because that wouldn't be fair if all the other pieces have 6. Would you want a bag with only 3 pieces? Here's our next example. A school has 324 students going on a field trip. Each bus can hold 8 students. How many buses are needed in total? So let's go ahead and reread. A school has 324 students going on a field trip. Each bus can hold 8 students. How many buses? So my equation is going to be 324. I do not know that grouping, the grouping being the buses, but I do know that there are 8 students on each bus. So as I do my work, I'm thinking, how many buses are going to be needed to ensure that all students are accounted for? So to begin, I know that 8 times 4 equals 32. So that means 8 times 40 is going to get me very close to that total dividend. So 40 is my partial quotient. And when I subtract that 320, I am left with 4. So not too many steps needed on this problem. The 40 represents the number of buses that will have exactly 8 students in each. So 40 gives me the exact 8. But what do we do with these extra 4 students? Do we leave them at the school? Of course not. They're going on the field trip too. So that means I actually need 41 buses. Will that last bus have 8 students? No, it will have the 4 students that we have left over. So here's an example of when that remainder actually has to be boosted up. We now come to my favorite part of the video where you are now going to pause and work independently. I'll see you in a moment. Okay, we are now at our answer page. I hope that your rounding ups or rounding downs looks exactly like mine, along with the appropriate work shown. And I hope that it was helpful. So please like, follow, and subscribe, and I will see you at the next episode. Are you looped in?